Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Charlie White. Soil testing is valuable to farmers because it helps guide important nutrient management decisions that can ultimately impact farmer yields, farming costs, and environmental impacts. But as farming techniques and best practices advance, it's important to keep tests up to date and calibrated to ensure accurate recommendations are made. In this episode, Charlie joins me to discuss his efforts updating the Pennsylvania Pre-Sidedress soil nitrate test. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Dr. Charlie White with us. Charlie is the Soil Fertility and Nutrient Management Extension Specialist at Penn State with a focus on agronomic crops. He has held this position since 2018 and previously worked at Penn State as an Extension Associate in Sustainable Agriculture and a postdoctoral scholar in crop production modeling starting in 2009. He has a master's degree in soil science from the University of Maryland and a PhD in soil science and biogeochemistry from Penn State. Hello, Charlie. Welcome to the show. How are you doing today?
Great. Thanks for having me on today, Abby.
Yeah, we are very excited to have you on. So today we are talking about some tests to help our farmers know how much to use when fertilizing their crops. So why don't you get us started by just explaining kind of the issue that your paper was hoping to address?
Sure. Well, the test that we're talking about is called the Pre-Sidedress soil nitrate test, and a lot of people abbreviate that just as PSNT. And the purpose of the soil test is to be able to have an additional tool to help farmers and agronomists understand what's the correct rate of nitrogen to apply to corn, particularly, although there are other crops that this test has been calibrated for instance, in New Jersey. Joe Heckman has calibrated it for a number of different vegetable crops, but it's mostly used for corn production. And of course, there's a lot of acres of corn across the country, and nitrogen is a very important nutrient for corn. It's used in a lot of, in high quantities, but it's got some potential negative side effects for the environment and also for cost of production. It's a very expensive nutrient, and it can be lost from crop fields in a number of different ways, either through leaching or into the air as nitrous oxide or ammonia volatilization. And because of all of these different loss pathways, it can be a challenging nutrient to manage. If you don't use enough nitrogen, it's likely that the crop yields are going to suffer, and so you lose money economically, so you don't want to use too much. A lot of farmers will err on the side of caution and use a little bit more than they might need just to prevent that yield loss, and that has negative environmental consequences. So there's a lot of work that the agronomy and soil science community has done over the years to try and improve decision-making around how much nitrogen to use. And one of the tools that has been around for a long time is this PSNT. And it was first developed in the 1980s and 1990s and has been widely adopted by farmers. But one thing about soil testing that's really important is the numbers we get from the test need to be calibrated to make recommendations. So you might get 18 parts per million of nitrate, or you might get 25 parts per million of nitrate. Well, what does that mean in terms of how much fertilizer should you add to your crop after that? And so we need to do field studies to calibrate those. And the original field studies for calibrations of most of the PSNT recommendations were done in the 1990s. And some states have periodically updated them, but in Pennsylvania, we had not updated them since the original calibration in the 90s. And so we felt like a number of things had changed in terms of our cropping systems that we needed to relook at the calibration of how we make recommendations from this test. And some of the things that have changed, we've got much more prevalence of no-till production. We've got more and more cover cropping. We've got higher yield goals or yield potentials with some of our modern hybrids. These hybrids are more nitrogen efficient than they were decades ago. So we really felt like the landscape had changed and we needed to update the calibration for this test.
Sure. Yeah, I remember when I was reading your paper, like for me, I was like, oh, this test is probably from like the 1800s, because clearly that's when they just decided all of the math for farming for the rest of all time must have been in the 1800s. It's like, oh, it's actually pretty recent. And then I had the moment of like, actually, that's still like 30 years ago. I'm a 90s kid, so it still freaks me out to know the 90s is getting farther and farther away. But I mean, in the history of agriculture, like pretty new. We've been agriculturing for a very long time. So I thought that was really interesting that it is relatively recent in the world of agriculture, but still we've made so much progress that needs to change. Update, I should say. And then one quick thing before we move forward, just so people are clear. Can you explain what sidedress means?
Sure. Yeah. Side dressing is a practice where a portion of the fertilizer, typically it's nitrogen, but it could be other nutrients as well, maybe sulfur, are delayed until the crop has already been planted and is somewhat established. And so in Pennsylvania, it's typically sometime in June, early June in the warmer parts of the state, later June in the cooler parts of the state. Depending on what region you're producing corn in, it could be May, it could be early July. But usually the corn is still short enough that you can drive through it with a sprayer. And so maybe it's, anywhere from 18 inches to 24 inches tall. And you put out the final dose of nitrogen that you expect your crop to need. And there's a lot of benefits to side dressing. So I mentioned all of these different potential loss pathways. If you put all of your nitrogen on at the beginning of the season, it takes about 6 weeks till the crop gets established and really has a big demand for that nitrogen. And so that's 6 weeks of loss potential where you could get leaching rains or denitrification occurring. And so it's really a best practice to split up your nitrogen applications and put a little bit out at planting to help the crop get off to a good start, but then delay the rest of it until right before the exponential growth phase and when it's going to be put a really big demand on for nitrogen out there. So that's what side dressing is. Some people call it top dressing. Other people call it side dressing.
Yeah. I appreciate you explaining that to me, because I always thought that it was like something to do with like the marginal lands on like the side of the field, because it's on the side. So I definitely needed that clarification. You're not completely wrong.
The reason side is in there is because a lot of times it's done with a sprayer with drop tubes that come down in between the crop rows and lay a stream of liquid nitrogen, urea ammonium nitrate solution to the side of the crop row. Oftentimes people that are doing it with liquid in these drop tubes, they call it side dressing. The reason I said sometimes people call it top dressing is because another way is to spin on granular fertilizer, urea, or a blend of urea and ammonium sulfate. That goes on as a broadcast, spun on across the whole field on top of the crop. Depending on who you're talking to and how they're doing it, they might use one term or the other term. But agronomists typically recognize both of those as a practice of going in mid-season when the crop is already established, driving through the crop and applying some additional nutrients.
Oh, I love that. That's my fun fact for today. This is great already. So I'm going to try to maintain some level of chill. So you were trying to kind of recalibrate this equation test that has been around for a while. So how did you go about that? What were your methods?
Sure. Well, you need to have some data to calibrate against, and the data what we're trying to predict in this case is how much nitrogen should be side dressed. So what we did is a number of field experiments. We had 45 experiments actually across a number of years and across a number of locations in Pennsylvania, where we would go into a crop field, and a lot of times these were on-farm experiments, so working on a production land with farmers using production scale equipment. We would go into a field of theirs and we would put out different rates of nitrogen at side dressing, from 0 nitrogen applied up to some very high rate of nitrogen applied. And our goal with those different doses, and we might have anywhere from 4 to 8 rates of nitrogen that we would apply. Adding those different doses, what we're looking for is a yield response. So as you add nitrogen, does the yield increase, and at what point does the yield flatten and plateau? And that generates what we call a yield response curve. And the yield response curve can then be used to figure out what was the correct rate of nitrogen for that field. And there's the rate of nitrogen that maximizes yield, but typically the economic rate of nitrogen is a little bit lower than that. Because the yield kind of starts to have diminishing returns, it starts to flatten at the top of the curve. Oftentimes, maybe the last 10 or the last 20 pounds of nitrogen you put out there, it costs you more to apply that nitrogen than you actually get in corn yield returned. And so the economic rate of nitrogen is typically a little bit lower than what it is to maximize the yield. So we use that response curve to find the economic optimum nitrogen rate for any given site. And then at each of those sites, we also pulled a soil sample for the PSNT, and we measured the soil nitrate in that. And the PSNT methodology, we didn't change anything about that methodology from when it was first developed. It was originally calibrated to use a soil sample that's 0 to 12 inches deep and sampled at an approximate growth stage when the corn is about 12 inches tall. And that's kind of a magical moment, I guess, in terms of when to do the sampling, because it's early enough before side dressing that you still have time to collect the sample, you still have time to send it to the lab, get a result, and make a plan. But it's late enough in the season that the soil has warmed up and microbial activity has started to kick into gear. And what the PSNT is really trying to measure is how much nitrate is accumulating in the soil as it warms up and microbial activity starts to ramp up. So you can't go out, first thing in March when you get a beautiful warm day and pull a PSNT sample because the soils are still cold. Microbial activity hasn't ramped up. Even at crop planting, microbial activity hasn't ramped up. You need to give it that time, going into June, at least in Pennsylvania, early to mid-June, for the soils to warm up and microbes to start cranking. So we pulled the PSNT sample, according to the original methodology. We didn't really want to change that methodology. Some people have argued, well, I wish it would have been calibrated on a 6-inch sample, or I wish it would have a different timing of calibration. We didn't want to mess with things too much in terms of people's methodologies, because to some extent that is already ingrained in certain agronomists and farmers' practices. So we didn't want to muddy the waters by changing that. But what we did want to do is just sort of tweak the formula that we use for that result and improve it for the modern practices. So those are what our experiments looked like. We tried to work on a variety of different farming settings. So farms that had lots of manure history, farms that used cover crops, farms that didn't use cover crops. We tried to sample a variety of different cover cropping practices, from monocultures of grasses and monocultures of legumes to mixtures. Some farmers like to kill their cover crops when they're small. Some farmers are getting into, these big, massive cover crops. They call it planting green. They let the cover crops grow an extra 2 or 3 weeks to produce a ton of biomass, and then they plant green into it while the crops are still living, and then they come back and spray an herbicide or roll the cover crop down, something like that, to get a nice big mat of residue. And those practices all really change the amount of nitrogen that will become available during the growing season. And so we wanted to sample a wide variety of those practices to see, is this test calibrated well. Another thing I'll mention is that we had a number of sites that use manure injection, and that's a new technology where liquid manures are mechanically injected into the soil with double disc openers or shoes that get pulled through the soil, and it's buried maybe 3 to 4 inches deep, and then in a furrow, and then the soil is kind of closed up over that furrow, and that really helps to protect against ammonia volatilization. And all that extra ammonium that's conserved in the soil instead of volatilized eventually turns into nitrate by the time you do your PSNT sampling. And then that shows up in the PSNT results, and you then can adjust your fertilizer rate according to how much extra ammonium your injection achieved. And so, manure injection is a relatively new practice in the last decade or so, but more and more farmers are adopting it. So we also had a number of sites that had manure injection. Sometimes it was the same field, and we had done a trial where manure was broadcast in 4 of the plots and in all other strips randomly applied. We had the manure injection, and so we had yield response curves for those 2 practices and the PSNT results for those 2 practices. And so that helped us generate a really wide variety of farming systems that we could test this in.
Sure. I have many questions, but I will restrain myself to just a few. So the first one, just to clarify a term, volatilization is basically just like evaporation, right? Of like putting whatever nutrient that is into the atmosphere.
Exactly. So it happens with the ammonium form of nitrogen. Ammonium is NH4+, and volatilization occurs when that ammonium converts to ammonia. Ammonia is NH3. And you all have probably used Windex or something before, which is an ammonia-based cleaner. You know how quickly ammonia volatilizes, how quickly it evaporates off of a window pane, right, when you're trying to clean a window with it. Well, imagine that as a nutrient source in your crop field, broadcast onto the soil surface. It's going to volatilize into the air and basically be lost. So you can easily lose 30 to 50 pounds of nitrogen from a manure application by leaving it on the soil surface, as opposed to injecting it immediately.
Wow. Yeah, that's not a small amount. So then my next question is you mentioned the nitrate and the microbes. So basically, I know this was explained in your worksheet you filled out for me, but just to clarify for people, the reason that you want that microbial activity is because that's when the microbes are turning nitrogen sources in the soil into a form of nitrogen that the plant can actually use. So the microbial activity is like an indicator of how much they're going to actually make non-plant available nitrogen into plant available nitrogen for like eventual nitrogen amounts in the soil. Is that correct? I'm sorry, chemistry people. I don't know the correct nitrogen, nitrous oxide, nitrate. I'm bad at that, so I'm just using nitrogen, but please correct me.
Exactly. So we're kind of working backwards in the nitrogen cycle. So I should probably explain it from in a forwards direction, right? So about 98% of the nitrogen that exists in the soil is in the organic matter form. And this is organic matter from crop residues, organic matter from previous manure additions, compost additions, cover crop residues. And that organic matter is not immediately plant available. Instead, it has to be broken down and have the ammonium released into the soil by the microbes. And so through that decomposition of the organic matter that the microbes are responsible for, they're releasing ammonium into the soil. And then very quickly, that ammonium converts into nitrate, usually if the soil is warm and aerated, usually within a week or two, that ammonium has converted into nitrate. And so in the early growing season, what's happening is you've got this mineralization occurring. That's the decomposition of organic nitrogen, mineralizing into ammonium, and that ammonium's converting into nitrate. And slowly your nitrate levels are building up and up and up. And then what we want to do is sample at a time when that nitrate levels are on the upswing, but early enough that we can still get into the crop and fertilize, right? So that's where we get this sweet spot of the timing in early to mid-June. And then the level of nitrate that accumulates in your soil at that time for sampling the PSNT is kind of an indication. It's like an early indication of what your mineralization rate is and what it will continue to be through the rest of the growing season. So if you kind of think about it as like a ramp or a ski jump or something like that, you're going to be going off of that ramp, and the height of that ramp is going to determine your trajectory through the rest of the growing season. And we can kind of measure the height of that ramp, that ramping up of the nitrate levels in early June, and make a prediction of what the rest of the growing season is going to be like. And so the higher that PSNT level is, the higher that ramp, It's going to be more mineralization from organic nitrogen, and you're going to need less fertilizer addition to meet the needs of your crop.
Okay, cool. That was my understanding, but I just wanted to make sure that we touched base on that. So this next question, I'm going to do my best to articulate it. So if I'm not clear, we'll just loop back around and try again. So obviously all of these fields have different management practices on them. And so my thought initially was like, well, how would you control for that if there's all these different factors that, does it have the manure or not? Does it have no-till or not? But my understanding now is that because the PSNT is kind of just checking where it is, wherever it's at, regardless of what you've done to get it to that stage, it's fine because it's just predicting from like where it is now, regardless of what you've done to get it to that number. Is that right?
Yes, well, it's a great question, and it actually goes back to some of our methods, some of our statistical methods, and we had a hypothesis that we wanted to test that maybe you did have to account for different management practices. So in our old calibration of the PSNT, we had what were called history factors, and there was a different history factor for whether the field had received manure in previous years or no manure in previous years, manure this year versus no manure this year, a previous crop of alfalfa versus a previous crop of soybeans versus a previous crop of corn. Those were all history factors that would be used to kind of adjust how we credit the PSNT result. And the higher your history factor, the bigger credit you would give to that PSNT in terms of reducing your nitrogen recommendations. So we had a hypothesis that all of these different management factors would play in, and you would have to adjust and account for them. It turned out that we didn't need to account for most of those history factors. The only thing we really needed to account for was whether the field had a long-term history of manure, and in which we defined as 2 or more years of the last 5 years manure applied. And if that was the case, then you basically use a single factor to adjust from your PSNT. Essentially, it was in English units, it was 4.9 was the factor. So you take your PSNT result times 4.9, and that's the amount of fertilizer you would subtract, basically. So the higher your PSNT, you subtract more fertilizer. We had hypotheses that would depend on the previous crop, whether it was corn or soybeans or alfalfa, that it would depend on the type of cover crop that was used. It would depend on whether manure was applied in the current year or not. And it turned out that none of those things really mattered. The only thing that mattered was the test was valid in sites that had the long-term manure history. And to me, that's really interesting, and it speaks to what you said, like you don't really need to account for all of those things because all of those different management practices are going to get baked into what the nitrate levels are going to be, and you just sample it then. And so if you have a cover crop that mineralizes lots of nitrogen, like a big legume, like a hairy vetch cover crop, it's going to mineralize a lot of nitrogen, turn to nitrate. You're going to pick that up in your PSNT test. If you inject manure and conserve all of that ammonium in the soil, it's going to turn to nitrate. You're going to measure it in the test. If you have a grass cover crop that's going to tie up a lot of nitrogen as it's decomposing, we call that immobilization. It's the opposite of mineralization. You're going to have low nitrate levels at the PSNT sampling, and that's going to guide you to apply more fertilizer. So it's really a nice test that integrates all these different previous management histories, kind of brings you up to date in the growing season where your soil nitrogen levels are at, and then you can move forward with some confidence. And I've talked to so many farmers and agronomists that they're scratching their heads about, well, did that manure, I broadcast it on the surface, but then it rained. And so if it rained, does that count as incorporation or not incorporation? Or I grew this big monstrous cereal rye cover crop. How much nitrogen is that tying up? I spread manure, but I didn't get a manure analysis, so I don't know how much nitrogen was actually in that manure, right? So how do I move forward without that piece of information? Well, the PSNT is a tool that you can use that just brings you up to date on everything that's happened in the past, and then allows you to move forward with confidence. And that's one of the things that I like the most about it.
Yeah, that's awesome. What a boon. I just love every time it comes up of like how complicated farming is. I'm just so floored. I just love farmers, and the work that they do is just crazy to me, in the best way. So the manure calculations, did it matter if it was injected or not? Did that have any play?
It did not. We didn't see any different history factor required for injection versus non-injection. So really, injecting the manure led to higher PSNT levels of higher nitrate levels at the PSNT test, and then that corresponded with lower nitrogen recommendations. So eventually what we found out after doing all of the statistics, we came up with a formula that you use to develop your side dress recommendation. And that formula takes your corn yield goal in bushels per acre, and you multiply it by 0.7, and that sets kind of a demand of nitrogen for the crop. And then what you do is you subtract off your PSNT level times 4.9. 4.9 is the coefficient, kind of the history factor, so to speak, if your field has a long-term manure history. So what's nice about that formula is it makes a lot of sense, because on the one side we have the yield of the crop, which sets the demand side of the story, right? The higher yielding crops are going to have more of a demand for nitrogen. But then you subtract off from that what your soil is supplying in terms of organic mineralization or conservation of ammonium from manure injection. You subtract that off, basically your PSNT level times 4.9, you subtract that off in pounds nitrogen per acre, and that gives you your side dress recommendation. So sometimes that equation might go negative, right? It tells you you've got more nitrogen becoming available than your crop is demanding. And what that is an indication of is that you don't need to side dress any additional nitrogen. And we see that in a lot of scenarios, a lot of heavily manured fields that have high organic matter levels, and maybe some manure applied at the beginning of the growing season, a little bit of starter fertilizer nitrogen, and then you get to pull the PSNT sample, you run that formula, you get a negative number, and it indicates that you're set in terms of meeting your needs for the rest of the growing season. And ideally that wouldn't turn too negative, because that would indicate an excess amount of nitrogen. And if you're doing this on a lot of fields and you're seeing they're all turning highly negative, or you're doing this several years and you're seeing they're always highly negative, maybe that's an indication that you're overusing manure or you're overusing some starter nitrogen and you need to kind of dial things back. I think the ideal, if you don't want to side dress nitrogen, would be to have that number be just slightly negative, and so that you have a little bit of confidence that you've got enough, or maybe a little more than enough, to meet the needs of the crop.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Charlie's paper, Recalibrating the Pennsylvania Pre-Sidedress Soil Nitrate Test Recommendations for Modern Corn Production, published in Agronomy Journal, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. I love that. This is so fun. So you've already talked about some of the results, but I know there were a few surprises. So can you tell me just more about what you found?
Sure. Well, one of the surprises was when we did this calibration that the history factor only applied for fields with a long-term manure history. And this was surprising for a few reasons. I guess, well, just because our old calibration had, you could use the PSNT test for fields that were not manured. You didn't really get much credit for that PSNT value. It didn't change it very much, but they still had a history factor. And so I think that led people to believe that you could go use this test in any field you wanted to, right? And so even in some of my research as a grad student in fields that didn't have a manure history, I had pulled these samples to try and interpret what the levels meant and how much fertilizer should be added. And that was all based on the old calibration. But with the new calibration, we see that without that long-term manure history, the PSNT really isn't useful at making an adjustment to your side dress recommendation. And so that was surprising, but it's also helpful to know that, because now we can rule out a bunch of fields that just you shouldn't even really bother pulling PSNT samples from them. A field that doesn't have that long-term manure history. So if you're an agronomist or you're a farmer and you're trying to prioritize, where should I go to spend my time and effort and money pulling these tests? Don't go to the fields that don't have a long-term manure history. Go to your fields that have a long-term manure history. Now in Pennsylvania, we're lucky, but maybe also cursed, to have most of our fields with a long-term manure history, right? That's some of our environmental problems with water quality relate to that long-term manure history. But we still have a lot of fields where this is useful in. But the fields that don't have animal manures applied, you can just cross those off the list for pulling PSNT samples.
Sure. I didn't realize it was like not useful as a test if you didn't have that history. So that's another fun fact for today. Does it matter what kind of animal that you're using manure from?
No, we found that it didn't really matter. So perhaps it matters, but we didn't have enough data to support the hypothesis that it would matter. We had 45 sites. Maybe if we had 1,000 sites or something like that, we could have pulled out some signal of different animal manure types. But we had sites with swine manure. We had sites with dairy cattle manure, with beef cattle manure. We had poultry litter. We had sites that anaerobically digested the manure. We had sites that separated solids out of the manure. We had a real wide variety of different manure types. And again, it was very interesting that it didn't really matter. Now, all of those manure types, they're different in their ammonium content or their organic nitrogen content, or how much might volatilize into the air when you surface broadcast it. But what was really awesome is that the PSNT result picked up all of that variation and, again, gives you information to move forward with. So, if you do the PSNT test, you might not even need to know what your manure analysis was for nitrogen, right? I mentioned that as a great example where there's so many farmers that they don't have a current manure analysis, or, maybe they have a manure analysis that represents the average of their pit, but at the beginning of pumping out the pit, you get really thick stuff. In the middle, you get, some more watery stuff. And at the end, you get some more thick stuff. And so you might have a good average for that pit, but different fields got different subsamples of that. And so how do you really be able to adjust for that? The PSNT is a tool that could pick up that variation in what the field actually received.
Sure. Oh man, that's just a rabbit hole. So I'm gonna not. Although I really want to. So were there any other surprises or results? Or if not, we can kind of move into future research, which we are a little bit touching on already.
Well, I guess another surprise was, I mentioned this formula has a coefficient times the yield goal, and that sets the demand of the crop. And under the previous calibration, it was 1.0 times the yield goal in bushels per acre. And for a lot of farmers, that number 1.0 is going to be a very familiar number. Some states it's 1.1, some it's 1.2, but it's sort of our yield goal-based nitrogen recommendations. You take this coefficient times your yield goal, and that's how much nitrogen to use. So under the old calibration from the 1990s, it was 1.0 times the yield goal. The new calibration, it was 0.71 times the yield goal. And that's 30% lower, right? And so what's going on that coefficient is now 30% lower in our modern production systems. And so we had, in our discussion, we had some potential reasonings around that. I don't think we can have a silver bullet to say exactly why did that change, but some of what we speculated is that we've got modern hybrids that are more nitrogen efficient, so they can produce the same yield with less nitrogen applied. And we cited a number of papers that have kind of documented that phenomenon of modern genetics being more nitrogen efficient. So we think that's part of the story. We also think that improved agronomic management of nitrogen fertilizers, so things like using urease inhibitors or nitrification inhibitors, just the practice of delaying some of the nitrogen till you side dress, all of those things are make nitrogen use more efficient. And so our data seem to indicate that production systems now maybe are 30% more efficient in terms of nitrogen if you just look at that change and what the coefficient is. So it's, that's a bold statement to make based on kind of a regression formula, but that would be one way to interpret it, is that we're 30% more efficient with nitrogen if you just look at the old versus the new PSNT calibration.
Sure. So where are we going with this then? Obviously, lots of ongoing room for growth. So what are we doing next?
Sure. Well, there's some questions that have come to my mind. I'm an extension specialist, and so I travel all over the state talking to farmers about this. And, now that we have a new calibration, a lot of my extension presentations include talking about the PSNT and trying to promote it to farmers. Just last week, I was up in the northern tier of Pennsylvania, where we're higher in elevation, more northerly latitude. Soils tend to be a little bit colder. And I was, to myself, kind of scratching my head, presenting to these farmers. And most of the data in our calibration came from central to southeastern Pennsylvania. I was thinking to myself, I wonder if this calibration is going to hold up for these folks up here in the northern tier. And, of course, I didn't sort of undercut my message by wondering that out loud to the group, but it made me think like, I wonder if we should have sort of some sub-calibrations for different regions and work more intensively with a group of farmers up in the northern tier to say, hey, does this really work out? Maybe do some validation studies to see how well it works out there. To take that thought a little bit further, it'd be really neat to see, does this methodology of calibrating the PSNT, could that work for other states? Could we go up into New York and maybe their coefficients are a little bit different because of differences in climate, but maybe the structure of the formula could possibly be useful. Could we go go south of us or go west of us into Ohio and see, could this formula be recalibrated? So I think that would be a really neat thing to do. And I hope if there's other researchers who are listening to this podcast, I hope you go and maybe be intrigued by the possibility of that. Go read the article, look at our methods, send me an email, and if you have any questions, that would be a really interesting thing to look at. So that's one aspect of future research. Another one that also I'm curious about is the sampling time, right? So we've got this old rule of thumb, sample when the corn is 12 inches tall. Well, back in the day, farmers were maybe more on a common schedule with each other, right? They all tilled their soil at the same time. They all planted corn at the same time. Everyone was more kind of in lockstep early in the season. Now we've got such a wide variety of different management practices across the farms. Not everyone is planting their corn at exactly the same time. And so people's corn is reaching 12 inches tall, not all at the same time. And so I'm wondering, okay, should everyone sample when it's 12 inches tall, or should everyone sample when maybe a certain amount of heat units have accumulated during the growing season? And some people, their corn might be 18 inches tall. To other people, their corn might be 6 inches tall. That question has come up in some of our recent on-farm trials where we have, a farmer that maybe waited an extra 2 weeks to let their cover crop grow, and then whereas the other farmers killed it when it was young and planted 2 weeks earlier. And so their corn is getting to 12 inches tall at different times. And so should we, when should we sample? So it would be really interesting to do a study where at lots of different locations, we sample maybe every week through the month of June and see how does soil nitrate levels change over that month, do a yield response curve in each of those sites, see what sampling date worked the best, was the most accurate. Is it the sampling date when everyone's corn was 12 inches tall, or is it the sampling date when a certain number of heat units had accumulated in the spring and the soils had warmed up and were starting to mineralize? I don't know. That's another one of the follow-up questions that I think would be a really interesting study.
Yeah, for sure. Definitely great avenues to pursue, and we'll have your contact information in the show notes. So if anybody is interested in that kind of research, you can reach out. So I have 3 questions left for you. The first one is, if listeners want to learn more about any of the types of things we've been talking about today, where can they go?
Sure. Well, we have a nice extension article about the new calibration, and so we can put that link in the show notes. And whether you're a researcher or a farmer or just a member of the public that's curious about these things, I think that extension article is a great way to kind of get the research digested in a very approachable way. If you're a researcher and you want to know all the nuts and bolts of how we did it, definitely go read the article. I'd be tickled to have folks reading it. In terms of learning more, one of the important things about all of these nitrogen management tools is that they rely on local calibrations. And so what I would encourage listeners who I'm sure, 49 out of 50 of you are probably not from Pennsylvania, that you go talk to your local extension specialists, your local land-grant university, your local agronomists, and say, hey, do we have a pre-Sidedress soil nitrate test that you recommend? How is that calibrated? When was it calibrated? How do you recommend I utilize that test? A lot of states will have a PSNT formula available or recommendations that are available. Some states won't, and there's sometimes good reasons why it's not available there. Either it's the climate or the production system has just shown itself to not be amenable to it. So if you have a PSNT available in your state, use it, right? Use it where appropriate, right? Follow the guidelines, learn more about it. If you don't have a PSNT available, then there are certainly probably other best management practices that you have opportunities to implement, and talk to your local extension specialists, your extension educators, your respected agronomists in the community and say, hey, what can I do to up my game on nitrogen management? And I think you'll get some good suggestions from that. So that would be one of the things I would recommend that folks do, is just, look locally to what resources are available for you.
Yeah, great advice. Great advice. So then the next question, which we've touched on just a little bit, is if people then want to take that next step and get involved, what else can they do besides maybe just using the test?
Well, if you're a farmer, I would say volunteer to do some on-farm research with, an agronomist or someone from the local land-grant university, because a lot of our work has relied on that collaboration with farmers to do the on-farm research. And I feel very blessed that we've got an active community of farmers in Pennsylvania that want to be involved in this and that have volunteered their land and volunteered their equipment and their time to do the extra yield checks, to do the different rates of nitrogen applied, to set aside the portion of the field that needs to be managed a little bit different for this experiment, to talk to us over the winter, to figure out all the logistics. So if you're a farmer and you want to help the discipline and the industry move forward, volunteering to host an on-farm trial is a great way to do that. If you're not a farmer, then maybe you're a consumer, right? I would say look out there in the marketplace, and maybe there are certain food companies or certain retailers that are promoting sustainable agriculture practices, or what a lot of the lingo now is regenerative agriculture. I don't want to name drop or endorse certain companies, but maybe like the big fish out there is Walmart, right? I just saw a press release that Walmart and General Mills were devoting a certain amount of money to promote improved agricultural management on certain number of acres as a sustainability goal for those two businesses. There's a lot of other food companies and retailers that are making similar initiatives, and so I would say start learning about those, right? And maybe if you want to support that movement in the industry, spend your food dollars on companies that are promoting those types of practices and they're working with farmers. One of the biggest challenges we have in agriculture is it costs more for a farmer to do some of these practices. They don't always get a positive return on investment. And so who's going to pay for that extra cost, right? As a society, we benefit from farmers improving their management. But do we always help shoulder the cost of those practices? And I think what these companies are trying to do is they're trying to provide some financial incentives to the farmers to help cover the costs of that improved management. And then as consumers, we can help support that. We can throw some extra dollars back towards products, towards programs that are promoting these good practices. And I think that's really important to do because as consumers, we can't sit there on the sidelines and complain and then go out and shop and try and find the cheapest food available, right? If we want to see improvements, we really have to help contribute towards the cost of that.
Sure. Great ways to get involved. Great advice on that one also. Last question for you. What is one fun fact that listeners wouldn't know about you if all they had was your research?
Well, me and my family, my wife and 2 kids, we love good food. We love cooking fresh meals. And one of the things that's sort of special about us, I guess, is we have a pizza oven in our backyard. We love to wood-fired pizza oven. It's made from local clay, sand, and straw mixed together with our feet and sort of packed into a nice sort of adobe-looking dome. But that was the first thing when we moved to State College, Pennsylvania in 2009. We bought our first house as a family, and the first thing we did that summer was build this pizza oven. So it was sort of like a foundational part of our lifestyle is having that. So we like to do that. The kids love to do that, love to build a fire and roll out the pizza dough and put the toppings on and see it cook in a minute or two and then enjoy it with some friends. So that's something, a little fun fact about me and my family.
Yeah. Do you guys have like a go-to topping set, or are you just whatever strikes you in the moment?
Yeah. Oh, yeah, we do. We have some specialty pizzas. I'd say one of our favorites is like a pesto base. And then we take some smoked salmon and a little dollop of cream cheese, roll up that cream cheese up in some smoked salmon and dot those little salmon rolls around on the pizza. That's one of our favorites. Really thinly sliced potatoes with some olive oil, sea salt, excellent. A little bit of rosemary sprinkled on top. You don't even need any tomato sauce or pesto or anything like that. But just really excellent flavor with that one. And then, of course, pepperoni.
So
Our kids
good.
love the
Yes.
pepperoni. We always have to make the pepperoni pizza first for the kids.
Right. Oh, man. Potato and rosemary is just, it's perfection. Now I'm hungry. Great. Well, this has been such a wonderful interview. I've had so much fun just learning a ton and exploring a really interesting topic that is obviously super helpful for our farmers and for the environment and everyone who benefits from that. So thank you so much for your time today.
Yeah, thank you for having me on, Abby. I really enjoyed this as well. I hope others enjoy listening.
Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.